Right. Other things we can do. What else can we do?
Let's see here. How about this? To the room and chat, what is one goal you have for the next 6 months? I'm lacking some motivation and direction right now, and I would love some motivation and aspirations. Does anyone want to start? Well, I'll start us off.
Okay.
My goal for the next 6 months is actually to apply to grad school.
Yeah, yeah, good stuff.
So I need to actually just do it, and that way I can get my no. Right, and I can move on with my life. But as long as it's an option that's sitting there, it will haunt me forever.
I've had 3 no's, so I gave up.
Yeah, no, yeah, fair. I think I need that in order to actually start thinking about what else I need to do. But I'll hold out like hope that they'll say yes, maybe with some conditions, but hopefully yes. And that way I can go and work on my PhD in chemistry, theoretical chemistry.
Nice. Your specialty was materials made from silver, right? Wasn't it?
Well, my honors project in undergraduate was running simulations on a. Okay, my honors thesis was in computational chemistry, which uses very, very big computers to test the properties of certain things. So I was running what are called DFT, or density field theorem, simulations of a unit cell, like a chunk, a repeating chunk, of polymer metal nanocomposite. So it was a chunk of polymer with metal discs suspended in it.
Okay.
And I was looking at its optoelectronic properties. So I was irradiating it from various angles and giving it to the computer to chew on for a while. And the results were promising. It showed a band gap in the visible spectrum, because what I was hoping for was a band gap means where it absorbs.
Yeah,
right?
yeah.
The wavelength of photons that it will absorb is, you have to do some math, but it's roughly corresponds to its band gap. So I managed to make a thing that might absorb photons in the visible spectrum, which is important because that's what we get a lot of at this level on Earth.
Yeah.
So it was promising. My supervisor thought it was promising. I got an A+ on it.
Nice.
Hopefully I didn't mess it up too badly, and those results were valid because nobody checked.
So from a I'm gonna do that thing that all science journalists do. Like, so what valid applications? Because there's always about applications, right? But it's like this is the kind of thing as terms of why would you want something that could absorb visible photons from the visible light spectrum, because that's something that applies to solar photoconductors, right?
Yes. So
you can make
visible
energy
light is
from
important
that
because there is what is called a frequency window in Earth's atmosphere. Earth's atmosphere absorbs a lot of ultraviolet, which is good for us, because otherwise we would have problems, and it absorbs a lot of infrared. Right, not a whole lot of it, but a meaningful chunk of it. And then, you also have radio waves and other things that are hard to, or tricky to interact with, or we don't get a lot of. But visible light is important because we get a lot of it. So if you want to have, say, solar panels, their characteristic that they need is to be able to absorb visible light. And one of the problems with solar panels is that usually it's like a layer of silicon and then a layer of some other stuff, and I've gone and done the easy part, which is finding the antenna, which interacts with radiation. But usually you need other stuff. But what you wind up with is usually this chunk of glass that is made up of many, many layers of potentially toxic materials, but certainly expensive materials. And it is the nature of a solar panel to decay after a while, because the act of absorbing those photons wears on it. It's like a car engine or a tire. Yeah. Right? As part of its job, it wears down. So you need to have things that can be recycled. And one of the reasons that I went back to school is I became fascinated with this idea of what is called cradle-to-cradle design, which is when we use the term designed obsolescence pejoratively, but it's actually quite an important idea as long as you're taking it holistically, because everything becomes obsolete eventually.
Keep going.
So what you need to do is you need to design everything we use with the idea in mind that eventually it's going to become worn out, or its purpose is going to become obsolete, or you just won't want it anymore. And so everything that goes into it has to have a plan for what to do with it when it's done. So if you're designing a, the example that is usually given is a shoe, right? If you make the uppers out of nylon, nylon 6, nylon 6 is a version of nylon that's easy to depolymerize. You can take it back down to caprolactam and then repolymerize it into nylon 6. But nylon 6/6, which is another version of making nylon, is like trying to unbake a cake. Right? So you have these choices that you can make because a shoe is going to wear out.
Yeah.
Right?
And do you want to be left with something that is purely unusable when it's done? Like, you can't even change it into something else.
Right.
Or do you want something that you're like, you know what, I could actually pull that back down to its constituent bits and then rebuild it, and even if it doesn't become a shoe again, it can still be something else.
Yeah, we can ideally recycle it.
Yeah.
Because we're here for the long haul. Whether you think of that as being like on the century basis, or on the millennia basis, or on the eon basis, right? We have to plan to be on Earth for geologic spans of time because we're never going to find any place that's more suited to life than here. Well, I mean, maybe we will, but that seems like kind of a long shot, right? And if you want to, you have to start thinking on those terms. So the thing that I was making was taking this idea of a solar panel, which is, you know, useful and important, and will probably be quite important to us over the next century, and making sure that it can be made in a way that is consistent with long-term human survival on this planet.
Yeah, and so whether or not your research actually leads to a practical application or not, that's not the important part. What's important is that you've demonstrated that there's some utility in creating materials like this, or there are ways to do it, and that might lead to further research that leads to even further research even.
Well, yeah. I mean, your PhD should be something important, but they're also a proof of concept that you're not a complete idiot. Right?
That's fair.
Like, do you have an idea? Okay, develop that idea, make the thing, do the thing. We're going to poke and prod at it and make you cry. And then once that's done, then, okay, you're allowed to now think about things professionally. Hopefully. Hopefully. Then you can go and look for a job thinking about things. And it's been years now since I've done that, and I was so happy doing that. Like in Mass Effect 2, when you do Morden's loyalty mission, he talks briefly, like you show him kinds of things around the mission area, and one of his dialogue options is he like takes this sharp breath and he says, happiest days of my life working on the genophage, right? Like brightest minds, unlimited resources. And he talks about like setting data to cook overnight, and then you examine it over coffee in the morning, and then you set more simulations to go, and that's what it felt like. Right, sitting in the library, because I didn't have an office as an undergraduate, but I got to sit in the UVic library, which has some quite pretty parts, and like sip coffee and work on my laptop, and that was way nicer than being in the lab, which is full of things that will kill me. Because I'm clumsy. As you might have noticed, I never miss an opportunity to just hammer my funny bone on things. Right? And when you put me in the lab, that's bad. That's very bad and potentially expensive. So I was way happier trading in my fume hood for time on the cluster.
So, then other people in the room, do you have a goal you're thinking of in the next 6 months?
Finish my honors thesis and graduate.
Yay!
Yay!
Yay.
Good luck with that.
Thank you.
Can you talk a bit about it?
Sure. Let's see. So my honors thesis, I'm still finishing up my undergrad in biology, and I've been working on my honors project, which involves microbial source tracking of E. coli in a couple of streams in Vernon, BC. Looking at a good measure, a standard measure of water quality is bacterial counts using what we call fecal indicator bacteria, which are specific types of bacteria that are associated with poop. Because that's important. You need
specifically
to know.
Human poop, or just any poop?
Just any poop.
Okay.
And that's where that's the standard testing. You just see how much of these bacteria are here, and it's like if there's too much, something that's probably pooped in it, that's probably bad. But microbial source tracking lets us get a little bit more specific, and then, as you say, like, is it human poop? So we've got a whole library on campus. We've got a big, nice database of DNA fingerprints of E. coli that come from the poop of animals and or humans that we know what it came from.
Mm-hmm.
And then we're getting water. We've had water samples sent to us throughout over about a span of a year. We isolated E. coli from those water samples that we got month by month, and then we pulled the E. coli out of that, sequenced the DNA of the mystery E. coli according to the gene we're looking for, generated fingerprints that we then used the magic of statistics to compare back to our library and assign a likely animal source of that particular strain of bacteria. So we're able to take these water samples, and instead, where the kind of first line of testing would be like, yup, something probably pooped in it, we can then go on to say, yep, something pooped in it, and it was probably alpaca.
Oh, neat.
So,
Yeah.
so saying it was alpaca, right, ties it into a likely source.
Yes, so in the Okanagan, it was funny because I was working, my partner in this project, Ante, who did most of the wet lab work and was fantastic, he's from Vancouver, and so he's looking at our results, he's like, why am I finding alpaca poop? But in BC, alpaca farming is a thing, especially for wool, for example. So that would indicate a strong livestock source, which would mean perhaps you've got agricultural land runoff, or what I've found is quite likely is also ranchers kind of not necessarily conforming to guidelines as to how close they let their grazing animals come to unprotected streams. That's a big one. But yeah, we can find, if we find kind of more anthropogenic sources, like either like human or, say, urbanized wildlife, like raccoon was a big one we were getting. That would suggest more urban runoff or, bad storm drain management, that kind of thing. And so the whole idea with this is, if whatever kind of poop there is, it's not going to be great. But if you can get an idea of what did cause it, you can then look at dealing with the source of the contamination and maybe putting in some preventative measures to keep it from happening again. So that's my work. I've still got a lot to do.
That's really cool, because it definitely feels like a detective story.
It is. It totally is. And had the chance to actually present the results of our research so far to our partners at the city, and they were really enthusiastic about it, and that was really exciting.
Did you do all your slides in Comic Sans?
I should have.
But you also got like the best question ever.
Yeah. Well, yeah. It was. There was without going, saying too much. I just went, one of our funding partners expressed an interest in perhaps providing more funding for future lines of questioning along this path. Yeah. It's very cool.
That's awesome.
Anyone else? Plans on the 6-month scale?
I'm gonna try and get my Cicerone level 2.
Oh, okay.
Yeah. For anybody in chat or here that doesn't know, essentially, Cicerone is to beer what sommelier is to wine.
Oh, okay. Oh,
yeah.
Okay.
Neat.
And I'm just got a new job as a bar manager at a record store back home, and so basically it's a way for me to have a piece of paper to tell people I know about beer, which will help me as I try to further career in beer.
Rad.
Sweet.
Anyone else?
Well, there's one thing I can't talk about yet, so
Cool.
I have to wait.
All right.
But hopefully taking and passing the MCAT.
Cool.
Nice.
Nice.
That would be one. So it's a big one.
All right.
Terrifying, giant one.
Yeah.
Yeah. Oh my God, so many flashcards.
Anybody else?
All right.
I will dig mine in then too.
Okay.
If I do not get this job that I've been wondering about next month, then over the next 6 months, it's to work an awful lot on prospective new merchandise for Loading Ready Run.
Cool.
We have some ideas for stuff. The problem is finding time and bandwidth and resources to actually make anything, and then deciding what's appropriate. And I'm really looking at it from a business perspective too. So it's like I'm using all these words, but it's like that's how I'm literally approaching this problem. And if I end up getting a job doing something else, then that process might slow down a bit, and we'll see how we tackle that. But yeah, if I do not, then we'll see what we can produce. So there may be new ideas for merch. We'll see what happens.